In this video, we have the integral of x over the square root of 9 plus 8x squared minus x to the fourth. Now, we did one similar to this in another video, except the expression in the under the radical or the radicand was a second degree trinomial, and we used, I believe, as a trig substitution. Now we have a minus x to the fourth here. So can we put this integral in this form? If we can get it in this form right here, du, let u be some expression, and if you get it in this form, du over the square root of a squared minus u squared, or a squared will be a constant, then the value of that integral will be the arcsin of u over a plus the constant of integration. We've used this formula before. You have one for tangent, you have one for secant, depending on what this is, whether it's an a squared minus u squared or a u squared minus a squared, or whether it's a sum of squares. Let's go back over here then, and this is what we're going to do. I want to factor out a minus from the last two terms here, 8x squared minus x squared, x to the fourth rather. So write this first, and then this will be a minus 8x squared, and then the plus 9 will be over here. That's the same thing, minus x fourth, x to the fourth, a plus 8x squared plus 9. So let's complete the square in the parentheses here. Since I have a coefficient for the x to the fourth term in the parentheses at positive 1, if I take half of minus 8, I get minus 4 squared, I get 16. This is now a perfect square. I can't just put a 16 right there though, because then it changes the problem. So it's actually a minus 16 I'm adding here, because the 16 is multiplied by this minus out here. So let's put a plus 16 over here. And then now, 9 and 16, that's 25. That's going to give me here. And then I'm going to rewrite this as a minus here. And then that trinomial is a perfect square. And it's going to be x squared minus 4. This is going to be my u then. So I'm going to let u equal to x squared minus 4. Then du would equal to 2x dx. And this is divided by 2 here. This will cancel out. And of course put the 2 over here. So now let's see what we can do with this integral. This is equal to then, okay, the x dx in the numerator, that over here, x dx, that'll be replaced by du over 2. So it'll be du, and I put the 1/2 hot in front, like that. And now, let's rewrite the radicand here this way. This is going to be 25 then, minus, and on terms of u though, x squared minus 4 will be the u. And of course this is the square here. So it's u squared. Now, this is the same formula I just showed you. It was a squared minus u squared. So the a squared in our case here is 25. So the a is equal to 5. And we can go directly to the answer. Now the fact that we have a 1/2 over here doesn't matter, because we just use this formula, and whatever constant's over here multiplies that answer. So this is going to be the 1/2 comes along for the ride. That's a 1/2. And I'm going to write it as arcsin. You can use sine or inverse sine. So arcsin, and it was u over a. But in our case, u is x squared minus 4. So it's u over a, that's u, x squared minus 4, and then a is 5. And then we have the constant of integration. So we have then 1/2, and again, keep in mind that this can also be written as inverse sine of x squared minus 4 over 5, but I'm going to leave it this way. It's 1/2, final answer then 1/2 arcsin of x squared minus 4 or 5 plus the constant of integration. Thanks for watching. We'll see you next time.